Oh, alrighty friends, I'll take some questions on that web work, but first I kind of want to come together for a second, talk about a few things. Let's kind of wait till everybody's here. Good. Everybody with me? More or less? Okay. Say about 90% of the way. I have a problem, so I'd like to see if we can solve this problem together. It's a Zeno plus problem. I'm going to try to make it to that wall, and that wall is 1 unit away. We'll just say 1 unit, because it's the distance I want to traverse. So, I mean, clearly the door is open, so I'm going to freaking keep walking, but I'm going to stop at the wall. I just want to get to the door, get the hell out of here, because it's Friday. And I've got this weird-ass OCD thing that I do, and I walk 2/3 of the way to where I want to go. And then I walk back 2/3 of the distance I've traveled. And then I walk 2/3 of the way left. So in other words, let me show you this. So my first step is I walk to 2/3. And then on the next step, I walk from 2/3 back 2/3 of that previous distance. How far is that? How far am I going to walk back here?
4/9.
Yeah, so back 4/9. Yeah. And then I'm going to walk forward 2/3 of what I just walked back. Now you can clearly see I'm not going to make it to the damn door, right? So this is why I'm stuck here doing math for the rest of the weekend. That's okay. So I get to here, and then I go forward 2/3 of that, which is 8/9. So plus 8/9. And then I'm going to go backwards. How far? How far am I going to move back next? What's the rhythm?
16/27.
Yep, because it's going to be 2/3 of that, right? So, but negative. So multiply that by 2/3, and you get 16/27. So I'm traveling 2/3 minus 4/9 plus 8/9. Whoa, that shouldn't be 8/9. That's fucked up. Thanks. 27. There we go. No wonder I never get anywhere. And then back 80, back 16, 81st, etc. Can you tell me how far I actually travel at the end of time? Just curious. I know I'm not leaving this room. Well, prove it to me. Yeah, that's no, you can. What kind of a sequence is this? What kind of a series is this? Right? The only freaking kind we know so far. We only know geometric series. Can you please add that up? First off, tell me, is it summable? Does it actually add to something? Does it mean anything to talk about it? What do you need to check for that? Is the common ratio less than 1? If so, proceed. Less than 1 in magnitude. Here we have a little twist on that. So please, all I just need to know is, where's my life going? Voign's got a really interesting, so this is the Voign hypothesis. Famous hypothesis in mathematics that we end up about half the way. We'll see. Voign's basically betting his entire academic career on this proposal being true, so it's important that we solve it. Your first step is to identify what is R equal to. It's the common ratio, the number I multiply between terms. Once you get in here. Okay. You can go do that anywhere. Can't do this anywhere. Although chess is a good game. Yeah, so what is your, so use, what's the top? I'm a little curious
I
about
did
this.
1 minus 0 because 0 is less than, or r is less than.
Oh, okay, so the top, so it's just the very first term. So whatever the first term is in that series,
Okay.
that just goes on top. Then 1 minus r. So you don't need to dig any deeper than identifying r. And then, what's your first term then?
2/3.
And so that's what goes on top.
Okay.
Yeah, yeah.
That's what I did, and I got 0.4 when you work this out. So obviously that's not right, because 1 minus r, which would be 2/3, right?
Yeah, yeah.
So this comes out to 0.4. So
That sounds about right. Why do you think that's wrong? It's curious.
Because it's not 1/2.
Well, it's just the Voyn hypothesis might not be true.
I don't feel
Voyn's got 1/2. This is great. This is good. We're gonna have a math fight off. I fucking love it. This is great. This is a good way to go out for the weekend. Punching series, dueling series. Somebody help me out. What's R?
Negative 2/3.
Beautiful, thank you. So we have this alternation here, so we have a negative r. We just need to check that the absolute value of r, which is positive 2/3, is less than 1, and I've got, if we can't do that, probably should have not been in calculus to begin with, right? We've got some other, like perceptive errors and things like that. Basic processing problems. So we got that. So we're good to go. So I can use this formula that this is since the magnitude of r is less than 1. Remember that the nice way to do this is it's the first term over 1 minus the common ratio. If this is true. If not, then all hell breaks loose. So let's see here. Our first term is 2/3. And then we have 1 minus negative 2/3. So be really careful down here because you got a double negative, and that's an easy thing to mess up. So then this is 1 plus 2/3. And then that bottom is 5/3. Yeah. Multiply top and bottom by 3.
It's 2/5.
That's 2/5. You were hella close. I mean, let's give the man some credit. He guessed it by just looking at the process, so lots of kudos for that. You're pretty damn close, just 10% off or so. But this ain't brain surgery. I'm trapped in the room forever. At least I get to do calculus. Any questions on that? Cool. Let's do another one. I'm gonna toss up some notation here. What if I have a series, so things are getting a little crazy now, and then n equals 1 to infinity. We've seen this notation before. It's going to become really important for us to understand what is going on here. So in here, I'm going to put negative 7/8. Oh, sorry, no, I'm not. What am I doing? I'm going to put in here 2x minus 1 to the nth power. That's what I wanted to do. Because you got a web work kind of like this. And I know we're going to need to talk about it. I'm getting all sweaty just from the Xeno games we're playing and the math battle. That was cool. So what kind of a series is this? Well, look at what we've got going on here. Let's write it out. The first term is 2x minus 1. I replace n with 1. Plus 2x minus 1, replace n with 2. And then 2x minus 1 cubed all the way down. And that just keeps on cruising. Do you see that that is geometric? So this is going to be like one of the skills you're going to develop over the next month. And we only have a month left, by the way. 3, because we're going to take a break, kind of. So 3.1 thirds, 3 1/3. So look here, what is R?
2x minus 1.
2x minus 1. I am multiplying by the same thing each time to get from one term to the next. Please make sure you see that, and if not, let's talk about it. really, really vital. Does that sound good? So this is geometric. And let me write up again here so that it's on the recording and it's on your notes. Geometric, because to get from one term to the next, we multiply by the same thing. By the same number, by the same quantity. Here it's a variable quantity. So the question, what question could I ask about this is, for what values of x does this series converge? In other words, adds up to something. Converge. And what does it converge to? So that's a much heavier question than we've handled so far. It's pretty cool.
Set 2x minus 1 like less than 1.
Yeah. We go to the condition. When would this exist? When could we sum this? So Isaac's hypothesizing that we're going to use this condition. So we use this. This is necessary for convergence. So we're going to set our variable quantity less than 1 in magnitude. Let's just do that, and then we're going to rewrite it instantly, because thinking in absolute values is, so we're going to set that to be the case. And we just need to figure out the x values that make that true. And you could eyeball a few. You see that x equals 0 is not going to work? Check that out, just to practice it out, right? Because because we get 1 over here. When x is 0, I get a 1. 1 is not less than itself. So that's not a way to proceed. What we're actually going to do, anytime you have an absolute value, you want to do anything in your power to get rid of it. So we're going to convert to a double inequality. And what I mean by that is 2x minus 1 is less than 1, but it also must be greater than minus 1. So anytime you have something like this, less than some number, b, that always can be converted into something like this. These are the same statement. It's just the absolute value is more compact. So now you have to solve a double inequality. Any suggestions on what I need to do? Because I want to isolate x. I want to get x right in the middle by itself. First step?
Add 1 to each side.
Beautiful. Add 1 to each side. So add 1 to this, you get 0. Ah, look, we can't be at 0. 2x less than 2. And then divide by 2. So 0 is less than x is less than 1. Aha. These are the x values that we can use. Any of those are going to work. What does this add up to? So let's assume that. Assume x is between 0 and 1. What's the sum? I want like a formula. So I don't have to do this each time. So let's write this up. So the series converges for these x values to what? What's the first term? It's going to be first term over 1 minus the common ratio. First term is 2x minus 1. Just, but trust yourself, right? This is just like read it. It sounds weird, but just go with it. So 2x minus 1 over 1 minus 2x minus 1 happens to be our first term and the thing that we multiply by each time. Simplify. So this is going to equal 2x minus 1 over 1 minus 2x plus 1. So that's 2x minus 1 over 2 minus 2x. And that's probably about, there's nothing else we could do here. You might be thinking there's some other algebra that could happen. And nothing that's super helpful. So we can literally go say, over here to the beginning, that this is equal to, we got a formula now, 2x minus 1 over 2 minus 2x if x is between 0 and 1. We've done something pretty heavy and cool. Like that. Does that make sense, everything? Yeah, Gabe.
How did you set up the inequality again, like -1 less than 2x minus 1?
So did you buy this guy
Yeah,
here?
yeah.
Cool. So this just means, that, let me give you a different way to think of absolute value. When I take the absolute value of something, I can think of that as its distance to 0. And distance is always positive, so this equals the distance of something, or from something to 0. So when I say I've got that absolute value of that something is less than some other number, so let's call it b, like a bound, that means that the distance of this stuff is never more than b units away from 0. So definitely can't go past that. I'm going to put a little open circle there. But I can't go the other way too, because that's also a distance of b units away.
Okay.
So I'm just converting this into a double inequality based on that right side.
Okay, so you can pretty much just put the negative of that right side on the left side as well.
Every time. Every time. Other questions? Other great questions. You should probably be able to do all your web works at this point, but I know that Gabe has a specific question on, I think it was number 6 or
Just
something.
number 5.
Number 5?
Yeah.
Yeah, so if somebody could bring that up for me, I'd be happy to address that, and then we'll just knock this stuff out. And on Monday, we're going to be pushing forward. Each day, something new and incredible is going to happen. Oh shit, I should probably erase the last thing I wrote. Something incredible will happen every single day in here for the rest of the semester. It has to. It is the nature of Calc 2. I am restraining myself so freaking much from telling you about the best math story I ever had, just so we can get this goddamn web work done. We'll get that web work done, and then I'll tell you, like, one of the most amazing math stories ever. It has to do with chaos. And chaos. Do I need to say more? So could I see that problem, please?
Yeah.
Thank you, sir. Beautiful. Okay, so what we got. So this is problem 5, and there is a lot of stuff going on here. Let me do a 5-ish. So we've got a sequence, a sub n. Notice they're using this brace notation. It's completely the same as we've had before. So I'm going to put -1 to the n, n over 3n minus 1. Anytime you get a sequence, my first recommendation to you is to just understand it by getting a few terms. Right, so just write out the first 2 or 3 terms so you can at least see what is happening here. So we can make a little list. When n equals, and see, they don't give us any subscripts here, so I'm just going to start at n equals 1. That's okay. So let's write here, when n equals 1, we've got -1 to the n, so our -1 to the first, that's -1 over 2. That's the n equals 1. And then when n equals 2, I'm going to get -1 squared, becomes positive. I've got a 2 over 6 minus 1, 5. Let's do one more. N equals 3, so this is n equals 2. N equals 3 is going to look like a -1 times 3 over 8. And then so on and so on. So that's what our sequence looks like. You look at that maybe and see if you can get any information, kind of like Voigt did at the beginning with that experiment, like just having an intuitive sense of maybe what's happening. This doesn't give me a lot of intuition. Maybe if I made a plot, that might help. So we could also go to the plotting apps that I've mentioned a couple of times and look at what the sequence is doing. Oh, is another good thing. So first thing, get some sense of it with just a few simple computations. Step 2, make a plot of it, right? right? So the first one's, let's say this is 1, -1, this is 1, -1/2, about right there. And then 2/5 is like 40%, right? We just had that, it was literally like right over there. So that's halfway, it's about 40%. And then the next one's -3/8. Is that higher than this point or lower? Is this like up or down?
Down.
It's down, right?
Smidgen,
Oh wait, yeah, oh wait.
It would be lower than.
I think it's a little up,
or
right?
up, I mean, yeah.
Because this is because -1/2 is -4/8. So it's not quite as up. So it's just up a little bit from this thing, like that. And then, you know, keep on doing that. But I would use an app. And I did suggest one to you. And if you still need one, I'll hook you up. So none of this helps. So that's what this problem's all about. How do you attack this thing? It's kind of weird. It's actually kind of like there's two sequences going on, and that's what they're getting at. So in the first part, let's see, so problem 1 says, is the sequence bounded above by another sequence? And it is, right? In fact, I could just pull the positive sequence here, everything's below that one. But here's a better way to do it. Just replace this -1 with a +1. So an upper bound is going to be upper bound sequence is going to come by replacing -1 to the end with just 1. So replace -1 to the end with good old 1, and then you'll always be below it because this thing is either at it or completely on the other side of it. Remember, this is just an upper bound. So the upper bound sequence, let's call it U sub n for upper bound, is equal to this sequence. And then you use this to analyze the rest of the problem. Like I can look at that and tell where it's going to go. Does this thing converge into what? Can somebody help me out here? As n goes to infinity, U sub n goes to what as n gets bigger and bigger?
0.
This is good, good. I'm sorry to be so joyful that you got it wrong, but. So what is the top doing as n goes to infinity? And I think Cam might have it here. It's going to infinity. What's the bottom doing?
Infinity.
Infinity. What do you use when you've got infinity over infinity? L'Hopital. Is that what you're going to say, Cam? You got a sense of where it's going? What do you think?
Is it going? Never mind.
So 1/3.
Yeah.
It's going to 1/3. Let's think of this another way. Lopi sounds low, but let n be 1 billion. 1 billion over 3 billion minus 1 might as well be 1 billion over 3 billion. It's 1/3. But we can L'Hopital this sucker. So we could easily see that this goes to 1/3. I'll just put L'Hopital in there. Put a little L''H because I'm never quite sure how to go with the rest of it. It's got some circumflexes, and I don't know, just go with that. Sometimes there's an S in it. Whatever. So this thing's going to 1/3, and so that helps me answer all of the first couple of questions on there. And I'm sorry, Gabe, I'll get those back to you
Oh,
soon.
no, you're good, you're good.
Okay, cool. And then they start asking us, okay, well, what about a lower bound? How do you think we're going to find that?
So I have a quick question.
Yes, sir. Yeah.
So for the upper bound, you just put in a +1.
Yep.
That's it?
I just thought, what's the most this -1 to the end could be?
Oh, okay.
And it's 1.
Just 1.
So maybe since we're talking, what's the least it could be?
1.
No, 1 is the most it could be. What's the least -1 to the end could be?
-1.
Yeah, that's the stuff. So to find the lower bound, I'm going to replace -1 to the end with -1. So for the lower bound sequence, we are going to replace -1 to the end with -1. And so our sequence, let's call it L sub n for lower bound, is going to equal negative n over 3n minus 1. Now, you become, in the last minute or so, if you've been focused here, a master of figuring out where such a thing would go, I think. Where's it going?
Or negative infinity.
No. Where's the, so the top is going to like negative infinity, right? And the bottom's going to where? Positive infinity. So that's still a L'Hopitalable thing. I still need to like get L'Hopitals in there. Or replace n with a really big number. What's negative, 1 with a friggin' lots of zeros over 3? 1, 2, 3, 4, 5, 6, minus 1. What's that quantity approximately?
About negative a third.
Negative a third. The negative 1 doesn't matter when n gets really big. So either way, let's take a look at this. I'm just going to write this out officially because I didn't do it last time. By L'Hopital's rule, since I have infinity over infinity, I can do the derivative of the top and over the derivative of the bottom. I mean, like, it's right there. Right? Literally, first application of L'Hopital gives me a sequence that never moves from minus a third. So here, L sub n converges to minus a third. So let's see, I think they're going to start pulling this together for us. Yeah. And then they ask for some specific numbers. Just pick the number in the sequence that's the biggest one, aka the first one. So, is this sequence monotonic? So let's look at the original sequence. Is that monotonic? Hell no, right? It's we had the picture. It's bouncing. Not monotonic. Is it converging? Let's talk here. I like that. I like seeing lots of head nods and with a sense of assurance. So let's take a look. So we've got this sequence and we started plotting out these initial values. But then we did this analysis that said there's this upper sequence that was converging to a third. So if this is a third, way out here, so let's say here's large n, the sequence is going to be near that value. It might be, it's not exactly on it, but it's, it's maybe right near it. Very close to it. Meanwhile, when n is large, we have this other sequence. So this is the upper one. We have this other sequence that's getting near negative a third. So way out here, I've got parts of that sequence hitting down there. Is the thing as a whole going to the same value? No. We've got one part of it going to positive a third, one part going to negative a third. So way out when n is big, it's just doing this. Right, let's think about this. When n is big, let's do this a different way. When n is big, what is this quantity approximately? Just that.
1/3.
1/3. So this sequence for large n is approximately this sequence. And what does that sequence do? 1/3 minus 1/3 minus the third, 1/3 minus the third, 1/3 minus the third. Shit ain't settling down. So it's this tail end behavior that really determines everything about convergence. And everything has to go to the same place. You can't have one part going somewhere, another part going somewhere. So this series diverges. That's all you have to say. Guess what yours will do. Alrighty, friends. It's your turn. I'm going to give Gabe his stuff back. You can rock this out now. There might be a few things to talk about, and that's why we're here today. You're so welcome. Yeah, Abraham.
So, what would R be for equation like this?
Ooh, neat. So, do you mind? Yeah. I just got a great question from Abraham. Let's talk about it, because I think we'll all be there at some point. Well, I was there like freaking 40 years ago or something. So, 30 years ago. Let's just give myself a little cut there. So we've got this sequence that looks like this. Ooh, yeah, this is a really good one, Abraham. I love it. So it's got like 3 to the n. Is that a plus in there?
Yes.
Yes. Plus 5 over 4 to the n.
Oh, one thing I think I wrote down wrong on there is that the plus is inside of the exponent up there.
Oh, the plus is inside the exponent. Okay,
Yeah.
that definitely
Yeah, I think
helps.
that's definitely.
I think we have another one like the thing I wrote, but that's okay. So like something like that.
Yeah.
Okay, what is the thing I recommend to do when we first have something like this? A sequence or a series, what's the very first thing to do?
Write out some of them.
Write out, to understand it, like own at least the first couple terms of it. So this is gonna equal, when n equals 1, we're gonna get 3 to the 6th, I'm not figuring that out, over 4 to the 1st. Does that make sense to everybody? Any questions on that? Good, okay. What's the next term? When n equals 2?
3 to the 7th over 4 to the 2.
Beautiful. And then we start to catch the rhythm here, right? Like it doesn't take long with this one. Next one is 3 to the 8th over 4 cubed, and so on and so forth. Oh wait, so I don't know why I said n equals 2 there. This is n equals 2 right here. So now, Abraham, check out how easy it is to actually figure out the R.
Yeah, I can get it with this one.
Awesome.
I thought it was outside of the
Yeah,
exponent.
easy enough. But once you get this, you can see that the R, what is my R here, by the way? It is. Just think about the top and bottom separately, right? From the top across, it's a 3. From the bottom across, it's a 4. And that converges, and I can rock the rest of it. I'm gonna miss you, Isaac. I'm gonna miss your joy, just your joy with like learning and life, and I feel like a kinship with you about it.
Ecology, I didn't like ecology at all. I was
Yeah.
just the opposite in that class. I like the really small parts of biology. I don't really care about the macro scale. Calculus is cool though.
Like I said, I'm gonna miss you. Yes. Ooh, what are these? Okay, gotcha. So you did this, so that, I agree. I totally agree. And then oh, but that's not your first term. Write them out. What does n equal in the first? There you go. That's the only problem you're having. I think if you put that in and do the simplification, right, everything will be cool. Well, the bottom, let's see, what do you got in the bottom? Yeah, I don't think this is simplified properly, because it looks like here, you did some simplification to get to that negative x minus 7, right? So you, yeah. Nice. Good work. It's good. This is the best chess. Was there a hand up on you? Becky, did you have your hand up? No, you're just like in there grooving on it. What's that? Okay, let me get Sophie and I'll be right back.
So my brain was obviously a little bit cloudy earlier this week.
It's okay. You got, yeah, fair enough. You know,
So-
you get like all the credit in the world.
Thank
so.
you. So it was asking to find whether the sequence converges or diverges, and then figure out the value of the first two. How do I do that again?
Okay, let me go do one on the board.
Okay.
This is like web work 11, number 1.
Yeah, I just don't remember how to do that part.
Do you need more time on that?
Probably not. I should be able to get
Okay.
that done. If I can't, I will shoot you an email.
Okay.
Thank you.
So in that one, we've got, let's make something up. So we've got like a sub n equals 5 plus, I'm gonna make my life a little more interesting than that thing there. So we got something like that.
Okay.
And maybe, was there a number in front of this part, like a 2 or something?
Yeah, it was
Yeah.
a -1.
Okay, cool. So there was this really important fact that you need for this, and it's that the limit as n goes to infinity of r to the n is equal to 0 if the magnitude of r is less than 1.
Right.
And then it diverges otherwise. Well, it equals 1 if r equals 1, and then it diverges otherwise. Does that all make sense?
Mm-hmm.
So what I'm going to do is look at this sequence and look at the different pieces. This 5 ain't going nowhere, right? 5's always 5. Plus 2 times this thing. Where is this thing going as n gets bigger and bigger?
Doesn't it go up and down?
It does, but if I use this tool here, right, because this is just a fixed number raised to a power that gets higher and higher.
Right.
What is the magnitude of this thing? Or is this number in here between -1 and 1? And so yes. So that means this piece goes to 0.
Okay.
As in, it does oscillate, like you said, but it dies out.
Okay.
Does that make sense?
Yeah.
Yeah, then it should just rock after that. All right, point. Yes, my friend. What we got? Oh, that's a good one. I'm going to talk about that one too. Okay, I'll be right back. Which one is that?
6.
6, thank you. We'll talk about number 6 on the new web work. That's the one I actually thought you were asking about earlier, Abraham. It looks a lot like it. Number 6 has something like this. I'm going to actually make my life more complicated than yours is probably. Let's see, so we got 2 in, plus 5 in, over 7. Got something like that. You cannot just add those that top is not 7 to the n by any stretch of the imagination, except for n equals 1. That's when that's true. That's the only time. So what you need to do here is rewrite this as a sum of 2 series. So this is this guy plus this guy. Does that help on that one?
Yeah.
Yeah. Then just rock each of those separately as geometric series. Yes.
So pretty much, just for all of these, we just have to use that formula,
Yep.
geometric formula.
So, yeah, write out the first couple, so you know what the first term is,
Mhm.
right? And then it's easier to see the common ratio, which you might be able to tell from here,
Yeah,
but I think it helps to just
Okay.
handle it. But yes, just like that.
thank you.
You're welcome.
I'm still a little confused on this.
Okay.
So that would be r plus 2 times 0, so that'd just be r plus 0.
Well, where's the, so, what's the R coming from? Where's?
I think that's what you pulled down. Oh, is that a 5? That's a 5.
That's the number that was in front. So this one's gonna be -4 minus 1 times a thing that dies.
So that one dies too, even though it's not negative?
When you say 2, explain to me. Yes. Oh, yeah. No, because look at the condition. It's okay. Oh, you're great. Look at the condition on the board. The thing inside there is between -1 and +1. So like each time n gets bigger, you're taking 40% of what you had before.
Okay. Oh, right. So
So-
you're looking at, and the only thing we're looking at that has any impact on r is whatever
Yes.
is being like touched by n.
Correct.
So this doesn't matter.
Absolutely. It does. It only matters that we carry it along. It never changes.
Okay.
So our answer is going to be as n goes to infinity, this doesn't move, so -4
Mm-hmm.
minus what as n goes to infinity? Where does that piece go?
0.
Yeah.
So it's,
Yes.
so it's just -4. Oh, okay.
Does that make sense?
Yeah, that makes sense.
Awesome.
So do you know what we're doing next Friday? That's the day I'm not gonna be here.
Do I seem like a guy who knows what's happening next Friday?
Ask you a couple weeks ago.
I know. We'll just, I got you covered.
Okay.
Yes, I really don't. I imagine it's gonna be series. I know it's gonna be series. I just don't know where we'll have gotten.
Okay. I should be okay though.
Oh, yeah, I'll take care of you. Yeah, and if you're not feeling okay, we'll make it better.
Okay, cool.
Don't worry about a thing.
Cool.
You work hard. That's it. Beautiful. Let's do it. Let's show me what's it gonna look like. Yeah, beautiful. Let's solve it together. Good stuff. Beautiful. Yeah. Oh no, actually, I don't think you're. So you're what? How are you moving from here to here? Actually, it's not right. You want to subtract 5. Yes, there you go. Yeah, yeah.
Thank you.
Yeah, you're welcome. Oh, that's your phone. That's a nice phone. I wish that was mine. Abraham, were you wanting to talk or?
No.
Okay, just stretching it out. All right. Run to the restroom really quick. I'll be right back. Oh, yeah, yeah.
This one was getting this into fraction.
Yes. Which problem is this, Abraham?
7.
Number 7. Okay. Number 7 help. And then I'll show you a trick. So number 7, it says do something like take 3.2815 and then only the last 2 is repeating and write it as a fraction.
No, it's just the 2 digits are always repeating at the end, so it's just like Mine is 0.3838.
Oh, that's what I mean, that, yeah, that's, I'm just having like 1 and 5 repeating.
Oh,
Yeah, so I'm with you. So this thing actually looks like this, so just to make sure, you know, I do know what you're wanting there.
oh, I'm just saying the first 2 decimals would also be 1 and 5 for that one.
Oh, wait, say that again?
The 2.8 would also be a 1.5. It's just the same decimals over and over.
Yeah, but these don't have a bar over them, right? Or
There's
did
no
they?
bars in any of it. It's just all the same digits.
Oh, wait, I must have totally misread that then.
Yeah,
can I see
so
again,
it's
please?
just 4.383838.
Oh, shit, oh, okay, gotcha. It looked like it had weirder numbers down there, but, cool. So just 2 digits like this, right?
Yeah.
Okay, cool. So with the number in front, yeah, we didn't do that. Here's a cool trick that does the same thing. If you have a repeating decimal, call it n, and then multiply it by whatever power of 10 is needed to get everything lined back up again. So notice that if I multiply by 10n, things wouldn't be lined up because multiplying by 10 moves that to the right. I want the decimals to line up, right? So that would be off rhythm. Because I want 1515, because I'm about to subtract and I want all that shit to cancel. So what do I need to multiply by? 100. So I multiply by 100 and then what do I get? So 100 times this moves the decimal 2 places, so I've got 315. 0.151515, and that keeps repeating, right? Because it goes on forever. Subtract 99n equals 312. N equals 312.99, 1/99. So that's a really slick. That's like I remember learning that like back when, like before I even knew about calculus. But that's a cool trick that you can use to knock that one out. Does that make sense, Abraham?
But how do I turn that into? Oh wait, no. It's just that's the fraction.
Yeah, you
there.
just solve for n, then you divide by this
Oh,
thing
okay.
that you got in the front of the n. And it'll always be like 9 or 99 or 999 or something. Yes.
Yeah, still struggling on number 1.
Okay.
I came up with that, so.
Okay, so let's see here. So I got that one. Okay. Oh, it's this one here. Okay.
Yeah.
Sorry. Okay. Okay. So your first term, I agree. Common. That's not your common ratio though. What is
common ratio is,
just 3/14? So it's you got the top right.
yeah.
But there you go.
Okay.
That's it. Does that make sense?
Yes,
Yes.
that does make sense.
Awesome.
Thank you.
Welcome. Look at your socks. Those are awesome. Those are amazing.
Pokemon socks.
Nice. Need some new fun socks like that. Oh, just add zeros. Let's make sure you got it right. Let's just check the work. So this, I don't even remember what the problem is there. Okay. So 2, what's the common ratio? 5/16, that sounds right. So that's gonna be 5/8. Yep. Okay. Yeah. Oh, okay. So when you multiply by 2, did you multiply by 2? Can I see the computation? round up then, that's, try to 1/8. Yeah, the 2 actually makes more sense given what they're, let's just try adding some more of those decimals in here. Let's go out a little further, go out like, put 5 of them down, maybe they want 5 significant figures. See, see. That's, okay, cool. Well,
Sorry, well,
I'm sorry. It's good, but I'm gonna shut this down.